Okay, the record is probably on. What I'm going to say now is not really related to this class, but that's why this class is important. So let's say you are going to design a beam. Oh, yeah, thank you. And close this too, right? Let's say if we're going to design the beam, you can do so. You can design the perimeter rafter for your house roof. Okay, you need to know the load, correct? Ask yourself, if you are going to design the beam for your roof, you need to know how much your roof is going to weigh, right? So you need to know what kind of roof tiles you're going to use, and according to the law, what kind of live load you need to put on the roof. So you need to know the load by yourself. You need to determine what kind of structure you're going to use. Correct? Let's say you're going to use a simple beam. And in the future, in order for you to have a simple beam, you must be able to make sure that you know how to create the pin support. Correct? And once you know the load, you know what kind of you have chosen what kind of structure you're going to use. You need to put this together and then perform structural analysis, correct? And of course, in the future, your system will get more complicated. As I once said in the beginning of the class, that you need to know how to analyze the more complicated structure than the ones that you are having now. So you must perform the structural analysis. Why do you need to do that? So that you get the maximum moment and shear and torsion and axial force, torsion, tension, compression, whatever. You need to know the maximum force that your structure will have to undertake, correct? And now you know this. You will probably, this is on the analysis side, okay? What we have here, you can say it's the, maybe. It's the demand side of things. This is the demand. This is what your structure will meet and survive. It's your job to make sure that your structure can handle these things. So in the beginning, you need to know what your structure needs to handle. And that's why this course is here, to teach you to find these things. And when you have the demand, you need to make sure that your demand will never exceed your supply. And your supply here, when you, can you recall this equation maybe? This is what you've done in your mechanics of materials class, right? You calculate the stress and then you measure up the stress with the given number. Ajahn Chulapot always gives you the number, right? The bending stress should not exceed this. The shear stress should not exceed that. That is the supply. But in the future, nobody is going to tell you the supply anymore, which means that you're going to need to be able to figure the supply yourself. And this will be taught in the classes such as reinforced concrete design, steel design, foundation design. You will be able to calculate how much one concrete beam can handle the moment, and then you make comparison with your demand. So right here in the university, it's not about taking the class to pass the exam anymore. So grow up. I don't know how I look. Grow up, because everything you learn, you will need to come back and use it one way or another. It's not okay. I made pass one exam and then I throw everything away. If you think life is that difficult, maybe getting a bachelor's degree is not for you. Remember, nobody is putting a gun in your head and say, you need to study engineering. You're here by your own will. Nobody is forcing you to do it. Except maybe some parents, but anyway. Let's say we have a common understanding that nobody can force you to study this difficult engineering at all. You're here because you like pain. Right? We need to fight each other to know each other. And now you know me. Now you know my exam is always, fun. Yeah, fun because let me ask you this. It used to be some kind of urban legend, you know what I mean? Right? That they say that every time there's an exam in my class, someone cries. That's some kind of urban legend. I don't know if it's true. So anyone cry this class exam? No, right? Maybe it's tear of joy, maybe? Tears of joy. Oh my, what exam? I have never had anything this ecstatic before in my life. I cried. Things like that. We have a full score, Okay, anyway, let's talk about the exam a little bit. Because I could not take the exam from, I didn't have it in the iPad. I always give the solution. So let's try to do this for a short period of time, okay? See if I can recall that. I think many students fail to notice that this is easy, okay? The first part. Thing is, let's say you're B1, correct? You're B1. So piece of cake, and still somebody cannot do it, but if you have a problem like that, you better make sure that you recover. So that becomes your tributary area for B1. But take a look at this. This is empty space. Oops. This is empty space. So this beam has only half of the area. So in analyzing B2, you should know that you have two different point loads acting on it, and then the self weight. Okay, B1 is simple, so I'm not going to talk about it. B2 should be like this, and this is of course the reaction from B1, and then this maybe I should do this. Okay, reaction for B1, and then another one is this. Some are quite good and recognize that, but say not much. And then don't forget that you have a point. Oh, sorry, I mean the self weight. It's pretty simple, right? You think it's difficult? No, it is. It's pretty straightforward, really. And okay, maybe I should mark the columns a little bit. So I don't know. Some of you fail to recognize the empty space here. It may not be absolutely crucial in the real world because engineers tend to use this beam and the green one here with the same size as this one for ease of construction. So this kind of mistake may not be crucial. But let's say if you forget the floor, if the mistake is the other way around, this time you forget that you don't have the floor. But let's say if there is a floor and you forget that you have it, that's going to be bad. Okay. So anyone making notes here? I'm trying to draw the next one. Okay. I don't remember what it is anymore, but maybe something like this. Okay, and then we have this. We have this, and then this, and then yeah, the tricky part Actually, this problem is similar to example that we did in the class, you know. So I was pretty, say, lenient in a way. You know, I was pretty not like me. Try to maybe give something that is close to the example in the class, and yet, you know, some has problem. And the direction of the floor is like this. Okay. So, right. B3 is nothing, so we're not going to talk about it. Okay. Except, let's say, that's a tributary area for B3. Okay. Nothing. Pretty straightforward. And then look at B4. This is the B4. Okay. Yeah, here is B4. Okay. So when you look at B4, and I said the cantilever portion is also part of B4. So for those of you who fail to recognize this portion, you get 0 right away because you're not looking at the correct structure. If you fail to provide this portion, the entire system will fail. Okay. And before, you should realize that, you know, whatever you do, you should always have the self-weight. But this B4 here has the special responsibility, that is, it needs to take this area. So you can say you will have 2 distributed load. Okay, this is the floor. And the floor, of course, that becomes a tributary width, you know, half of the internal span and then half of the one outside. Okay, so that's your B4. Any question? See, it's pretty straightforward. And the important point that we made in the class is that if you face a situation like this, guys, somebody's still taking notes. Okay, I'll wait for 30 seconds. Okay. Okay. Are we ready? Maybe not. You know, I like this classroom in particular. It has a nice atmosphere. And, you know, I have to say, this is not the first time I'm talking about this, but I'm a little bit surprised that not many students show up in the classroom, not even 20. You know how big our class is? 88 students. It's quite big. And I thought that, wow, students would like to come back on campus. That's why I'm offering myself to be here. And I'm more than happy to do it. And we're going to have the active class tomorrow here as usual. So please feel free to come in so we can enjoy each other again. All right. So it's a little bit of a surprise. And I have been told that some universities now make it mandatory. You know what that means? Mandatory, compulsory, but it means that you need to come back on campus. But here, teacher, yeah, I don't want to make decision because blah, 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 blah. So yeah, but I can make my own decisions. I can take my responsibility. So that's why I'm here. And okay, you guys are done. So if you can recall, this is from example, the first one that I tell you that if you face a situation like this, where this beam comes in here and that beam comes in here, you need to make sure that these 2 beams survive by themselves. That helps a lot because you never know, when they do the construction, which one they're going to build first, right? So the best way just to make them strong enough to handle themselves. Many are okay, but for those, some of you will put the point load from B5 or B4, B4, B5, but that is wrong as well. Okay, so we move on to B5, which is this one now. Oops, sorry, not that one. This one. That's B5. So I do this. So B5, you're gonna have 3 point loads coming in from B3, a little bit tough, and then 1 uniform load. The cell plus the floor. Okay, and the floor in this case is now going to be just half of this. Okay, it's pretty simple, really. So I don't think it's a good idea to say it's easier, it's difficult, compared to last year, the years before, but this is the system that you should understand. Because if you don't understand the system, you don't understand how much load your structure need to carry. So when you don't know the load on the structure, how can you calculate the internal forces your structure require to withhold, right? So it's building up from step to step, and this will lead you towards a proper civil engineer. And then that's it. Any question? And a little bit about problem 1, but it's really short. Okay, are you guys taking notes here? Are you? Are you taking notes? Then yes, but then you just don't do anything. Just sit there. Are you taking notes? Yes. Are you not taking notes? Yes. Are you okay? Yes. Are you not okay? Yes. Yes. So should I carry on? Yes. Should I wait for you? Yes. Right. Anyway, for problem number 1, it's pretty simple. I think many figure it out. So the thing is, they forgot this load, right? Forgot them. Simple as that. Okay. All right. So I think it's high time that we resume our challenging structure called frames, right? So you guys ready? We're gonna have the homework for the frame coming up soon enough, I suppose. And then before you know it, the second exam. I like this format because at least, let's say, if you have the frame and the floor system together for midterm exam, it kind of gives you a short notice to wake up, right? Now you are awake. So, and I expect you to do better in the second exam. So here it is. Ooh la la, what is that? Picasso. Calculate reactions at the frame shown in the free body shift force of the frame. So we know what to do. Now, how many reactions do we have? 3 as usual, right? And that means it is a statically determinate structure. Let's try to write it correctly, okay? Statically determinate structure. In this case, a frame. All right. Now, when I look at something like this, I think it is pretty normal. When you try to analyze the frame of the factory or warehouse, it ends up looking like this. So it gives you say basic overall understanding of what the frame may behave. And when I see things like this, I would love to use superposition right away, because I can see that, you have a frame. I can break it down. Oops, don't look like much. Into a frame like that. With that, 15, right? Plus another one. But, it doesn't mean that you have to do it the way I do. Than that. But for me, it's easy. Because the 15-ton point load is acting in the middle. So right here, if I break it down into two cases, on the left, I have symmetric situation, correct? Which means I can tell right away that this is 7.5 and this is 7.5 without doing anything. Can you see that? I think it saddens me that some students still don't know what symmetry is. Yeah, you sometimes when you express when I was your age, I would act surprised as well. Some of your friends, they don't really recognize this, so they fail to take advantage of the situation. And for example, in exam number 1, it's symmetric, isn't it? So you could actually calculate everything in less than 5 minutes, taking advantage of symmetry. The reaction can be done just like that. Everything divided by 2. Some take moment and do it wrong. So really sad. It's like a gimmick when you see the symmetric structure, And then here 6 tons. Now, again, as usual, if you can see, remember that I told you the reaction of the statically determined structure doesn't depend on the shape of your structure, correct? I can draw a box here. I can draw a heart here. I can draw a shape of a tree here. It doesn't change the reaction. And when you look at the system as a whole, this 6-ton horizontal point load is trying to rotate this one counterclockwise, right? Can you feel that? So we need clockwise moment, right? And you should feel right away that, well, of course, we need another 6 here. That's a gimmick, right? Otherwise, our sigma fx is busted. So it's a gimmick that you need another 6. And it's going to rotate your frame simply because these two 6s, they don't pass each other. They do not coincide. So they are going to rotate our structure. So the moment here, if you can recall your statics, it's a 5 meters, right? So here is the moment caused by this load, 30 ton meter, correct? So we need the clockwise moment to counter that. So I'm going to give the force, but look, the external force does not have the vertical component. So that means you should know right away that your reaction must be equal and opposite. Otherwise, your sigma Fy is busted. Can you feel the equilibrium? Yeah, one thing I can never stop doing is screaming while in lecture. Just gotta get myself into it. Can you see that? You need the clockwise, but at the same time, your two forces will have to be equal and opposite because you don't have the external vertical force acting on your structure. So it's automatic. Whatever we do, equilibrium comes first. Okay? And this couple need to give you the clockwise 30 ton meter. And now your moment arm is 8. So this is essentially 30 divided by 8. Remember a couple, right? Now we have a counterclockwise couple of the two sixes multiplied by its respective moment arm is 5, so it's 30. And now we have the 30 over 8, a couple of 30 over 8, and it has the moment arm equal to 8. So when you multiply them, they give you 30 Nm of couple. You don't need to do any of this. You can just, why do you need to do it the difficult way? Can I just take moment at this location? You ask me, can I just take moment here? Of course you can. But I want you to feel the structure. It's not just about calculation. You can perhaps go on, calculate so many things, but you don't feel anything. It's like Celine Dion singing, you know, singing without emotion. It's bad. Why didn't happen? Anyway, maybe somebody likes Celine Dion so much, right? Anyway, so that's what it is. So now we have it. Okay. Any questions? I better move on. So I don't seem to be able to draw a good straight line. So let's begin here, okay? Or maybe here. Not very straight. Maybe I should use that. Okay. That's better. Okay. Now we have a hinge here. We have a roller here. These are our external force. Forgive me for not writing the unit. Okay. And these are our reactions. Oh, you know what? You've got to add them up too, right? So maybe I need to put a number. That is 3.75, right? Am I correct? Help me. I'm full. Right? I think it's correct, right? So plus 7.5, how much is that? 10 something. Huh? 11.5. Point what? Okay, 11 and a quarter. But now here, it is 7.5 minus that. Oh, really? Right? So you see, when you look at your sigma Fy, they go up 15 in total. So we are in good shape, right? So why not? Let's go on. Okay, this problem is still simple enough. So you want me to wait for you? Wait for me, please. They tell me like that, okay, so that I know. But think to be okay. So here we go. Let's focus on AB. And again, let me tell you one more time that when I grade the frame problem, I will grade by the level. Okay, so that means you need to complete every free body diagram first before you move on to shear force diagram. If you can finish only one member, then you write free body diagram and then shear force diagram and bending moment diagram. I will not grade your shear force diagram of one member. You need to provide the free body diagram of every member first to show that you can actually write proper free body diagram of your frame. To write free body diagram of one member doesn't count as, you know, knowing how to take care of free body diagram. So let me say here, complete free body diagram of every member before say calculating shear force diagram and bending moment diagram. But that too, you know, complete shear force diagram of every member before you do the bending moment diagram. But once you have the free body diagram installed, the rest should be piece of cake. Okay, so AB. Let's put the reaction in pink. 11.25 up, and then 6 to the left. Okay, so that's the force at one end. You should notice by now that what we need to do is just to complete the internal forces, external forces at every edge of the member. And here is member AB. We may call this NA, and that N is B, which is where the joint B is. So it's simple enough to know that if that's 6, this has to be 6, correct? I don't need to write sigma fx equal to 0 so that you know this is 6, right? And then this is, of course, 11.25. But you should notice by now that this is not equilibrium. The two 11.25 forces, they are axial forces, so that they coincide. That's done. But the shear forces, when you have the shear, you're going to have the moment, correct? And the two 6s, they don't pass at the same point, meaning they are going to rotate your member. So you must know now that you must require the moment. And this is counterclockwise, so you need to have clockwise moment here to balance everything, correct? You can, there are so many ways to feel this. You can look at the two 6s and you know that they are going to rotate your structure, so you need the moment. Or you can just look at point B. You take moment at B. And some of your friends, as they're taking notes, look at this first. If you take moment at B, you would feel that this 6, the pink one, will try to move your frame to the right. They're trying to rotate your frame in counterclockwise, and some of you say anti-clockwise, right? But I don't think it sounds cool. It's my personal preference to keep saying counter-clockwise. Sounds kind of a little British to me, you know? So I hope that's okay. So you can see, you can feel that the pink 6 will try to rotate this member counterclockwise, so you need clockwise mode. You can also say, okay, sigma, not here, maybe here. Sigma MB equal to 0. So MB is simply 6 multiplied by the length of the member, which is, I think it's 5 meters, right? So incidentally, that's moment is 30 ton-meter. Okay. Now, your member AB is under equilibrium. Again, okay, I think I'll give you a 1 minute catch up. Any questions? It goes so smoothly, no questions at all. I don't think that's possible. At least you must have some question. What? Any question, please? Nothing from home? Nothing from here? Is it crystal clear? Yeah? Is it not crystal clear? No. Okay. So we can move on. Now, some of your friends are still doing something, so I'll give them a minute. So you should, you know, I can tell you that if you really want to help your friends, you ask them back, let them try to explain back to you. Because believe me, if you keep explaining things to your friend, it is you who gets better. They will just remain the same. Because you're not saying anything different from what I do, right? What I say, except maybe in your own language. So your friend is listening to the same thing. How can doing the same thing can get you better? You know the famous quote from Einstein, right? You keep doing the same thing, expect different result. You know what they call? Insanity. So if you really want to help your friends, you must give them opportunity to try to explain things back to you. And you listen and correct them. That's the proper way to help your friend. If you take control, if you explain everything exactly the way I do, what difference does it make? You're just doing the same thing as I do. If I do it, your friends don't get it, you do it again. How would they get it? Maybe I'm not good enough. Maybe I should let you guys do the job. But I'm not saying that you're not good enough either. But I'm saying you need to find a different means to help your friends. Right? Okay. Now, folks, you can look at this. Now we have 3 members, correct? But some of you may notice already that you have a choice. You may begin your next work from member BC, which is this one, or member CD as well. And then you shall face the truth at BC, see which under equilibrium. I think I've done A, B, B, C, and CD for the first example. So it's not a bad idea to try DC this time. Yeah. All right. So are you excited? You want to do it yourself? Maybe. No, I'm not awake yet. Okay. It's still too early. Okay. All right. So maybe it's not a bad idea to try to do member CD or DC, whatever you call it. I need to take my glasses off. And D. And we only have 1 force here, and rightly so, because you can't have the horizontal force at D. It's a ruler. And when you cannot have, you may want to take note, okay, no horizontal force here, because it's a roller. So that means sigma Fx will tell you that C cannot have any force. Right? Otherwise, your sigma Fx will not be satisfied. Meaning, the only thing that your member CD can have is another axial force to balance sigma Fy. Where are you going, man? My what? You have to go to toilet now, otherwise it will be catastrophe, right? It's called the force of nature. Okay? No one can stop him, even his parents. So who am I to stop him, right? Anyway, so here is the 375. You know that much. I can't hear you. Can you speak up, please? Excuse me, folks at home, I need to get close to your friends. I still cannot hear you properly. I'll come back in 10 seconds or 30 seconds. Yeah, right. Let's go back up. We have a problem with the reaction a little bit here. Remember, this is our system. This is our equilibrium of the system. When you look at member CD, it's right here. And at the support D, we only have the vertical reaction of 3.75 tons going up. So when I cut the free body diagram of this member, only this one shows up. Your friend asked me about the 7.5, but remember, I split the load case into two cases. This 7.5 is the one corresponding to 15 alone, and the reaction must be this 7.5 add up to this one, which is a downward reaction. That's why we have 3.75. You don't need to do this. You don't need to split the load cases up to two cases like what I do. You can just take the moment, but I kind of like to do this because I don't have to do any calculation at all. I don't have to take the moment sigma MA equal to 0. This force multiplied by that force multiplied by this force multiplied by that, and then everything divided by this to give me the reaction at D, you know. This, you can just do it with ease without any calculator. Okay? So we're back in business. Here. Now, you guys should know by now that this is what we call a lean column. You see? Because you cannot take anything. And you must be true to yourself when you write the free body diagram. You can't have anything more than this, correct? Unless there is external load. But member CD does not have any external load. So, you know, it has to be like this. So now it's time to complete our member BC. We have a break, right? Maybe I should erase this because it gets in the way. And it may mislead you. So member BC. Now you know, because your member AB, now look, before you do anything, look at your member AB. You all agree that this is under equilibrium, correct? So that means all the forces at joint B here must be transformed to joint B here in the opposite direction. Should be that simple. And let me try to use different color, maybe to give you some idea. If it's 6 to the left, here is 6 to the right. And if it's 11.25 going down, so it is going up. And if it is clockwise moment here, now it is counterclockwise. 30 countries. It's a simple force transfer from one member to another at the joint. But don't you forget that we have the external load here, 15, right? And when we look at another joint, C is 3.75 downwards, so it's upward here. So voila, at least sigma Fy is going to be 0. Now it's like French. 0. Okay, so when you look at this thing, you want to make sure that everything is under equilibrium. So if you want to make sure, you can try sigma MC equal to 0. You take moment at C, which is this point, and see if MC is actually 0. Okay. So now, what we are going to have is that I hope that when you come to this point, You know, I don't do clockwise, positive, counterclockwise, negative anymore. Maybe you want to do it, it's fine. But you should practice until you don't have to do it. So I see the way I see it. 11.5 is pushing up. Multiplied by the length, I think it's 8 meters, right? This 30-ton meter is pushing down. So it goes in the same direction as this 15 external point load. Is that 0? I bet. If not, be in trouble. Yes, right? So it's time to celebrate. Yeah, we are under perfect equilibrium. Yeah. Why this does that? I don't know. Must have and I can't say put it down because you know folks at home will not hear me. Sorry about that. It's like in a concert. So it's 0, which means if you begin your work from member BC first, it better be 0. Right? And the 6 ton, don't forget, you're gonna have your 6 here to balance it out. So the perfect free body diagram of this, oh, you bet pretty quickly. Not as bad as we all think. Get to your position, please. Can you sit? Can you sit? Maybe it's so painful you can't sit down for a moment. Yeah, you've gone to heaven and back. You can say that, right? Anyway, you know, forgive me this by we have a foreign student, right? But in Thailand we call toilet the sukha, right? Because it's a place where you go and you become happy. Right? Yeah, it's you know, for the one who comes up with this word, I think genius. Right? You find happiness in toilet. Maybe. Anyway, wow, I forget that we are recording this, right? So it's in the record. Anyway, oh, okay. So you see, that's the point. We have 6 here, but the 6 doesn't come here. And the answer, if you really want, is in the free body diagram of the joint. Because when you write the free body diagram of joint C, you have the 6 coming in like this. And then that's where the external load is applied, right? It's gone. It's right there. It's balanced at the joint. So maybe that's why it is not a bad idea to be able to draw the free body diagram for a joint to help you clear where the point load that is applied at the joint may go. Okay. So let's complete this. This is going up, so it's going down. That's a complete one. Okay. And no moment here. So it goes up here, so it comes down then. Okay. So we have completed the free body diagram of every member this frame, and the time is up for the first session. So I think it's high time we take a break, 10-minute break, and we're gonna come back and finish this problem. Okay. Right. We took the time to talk about the exam. Okay? So that's it. All right. Any question? No. All right. All right. So some of your friends are still taking notes. So I'm not starting the break yet. Okay. So that we are, you know, I'm not taking advantage of your break. So let's take a note for some minutes. Okay. Excuse me. Okay. All right, guys, I think we are ready to take a break. But let's say we will start the second session about 10:35. Okay. So if you have the urge to go to 7-Eleven, for example,